we're up. So we're going to do problem 21. We got a system of equations here, and then it gives us possible solutions for this system of equations. It says that it gives, these solutions like as a coordinate pair x, y, and look, it's got like another variable r, which is like a parametric variable. It's like a slider which can be used to um, slide along a line, just like the solution to this is a line. So let's look at these first two lines first. I'm going to solve it with algebra first, and then we'll look at the desmos solution. So to solve this with algebra, you would look at this and you say, oh, okay, I'm going to figure out what xy point satisfies these. And then if you did, you might try to eliminate the x or the y first. If you did, maybe you're like, okay, I can make this 2x into 10x by multiplying by 5. What if I multiplied the first equation by 5 and then I subtracted the 2 or something, did elimination, right? So if I multiplied the whole thing by 5, I would get 10x plus 15y equals 35. And then you notice that the two equations are the same. So actually these two equations are describing the same relationship. They're two lines that are on top of each other. So you only really need to look at one of these equations because they're repeated, right? So these two lines are on top of each other. Then it asks which one of these sliding points is exactly on top of this line. Let's say the 2x plus 3y equals 7 line. Now what we're going to do is we're going to consider each one of these to be an xy pair. So this is x and this is y. And if we put this in there, either a certain r is going to make it true sometimes, but it says for each real number of r, which of the following points lies on the graph of each equation for the given system? They're saying like when is this coordinate pair point always on this line, right? Because it says for each real number r, for all real number r's. So how would we confirm that? We would basically substitute each one of these xy's into our representative equation, 2x plus 3y equals 7, to see if it turns out to be an always true statement. So first we'll put this one in, and we'll say 2 times r over 5 plus 7, which is the x value, plus 3 times negative r over 5 plus 35 equals 7. And so if we look at this, we're like, let's see, if I distribute 2 here and if I distribute 3 here, does it look like I'm going to get 7? Well, I got 2/5 r plus 14, and then I got negative 3/5 r plus, and then I got 35 times 5, which is like 105 equals 7. Well, first of all, if I add these two up, I'm just going to get negative 1/5 r, so I'm not getting rid of the r, so there's no chance I'm going to get 7 equals 7, right? So this is doomed. Okay, let's try the next one. So this next one here, I'm going to put 2 times negative 3/2 r plus 7/2, and then I'm going to put plus 3r equals 7. And then if we distribute this 2, I would get negative 3r plus 7 plus 3r equals 7. Oh, look at that. The negative 3r and the positive 3r cancel out, and I end up with 7 equals 7, which is always true, which means that this xy pair always solves the equation 2x plus 3y equals 7, and these two equations are the same. So the answer is B. Okay. How would you do that with desmos? Well, first of all, the first thing you want to do is you want to see what the solution of this system of equations is. So we type 2x plus 3y equals 7 in, we get a green line. Then we do 2x plus 15y equals 35, we get this purple line. Look, they're on top of each other. Okay, so we realize that they're redundant. We only need one of these equations to really check the solutions here. Now we're just going to type in each one of these xy pairs, and desmos is perfect for this because desmos allows you to make r over 5, the parametric variable, into a slider. And once we do that, we can see that, oh, actually, if we just slide r back and forth, it is obviously not on the green line, right? It's way up here. So let's try another one. Let's try the pink pair here. 7/2, comma, r. And then we can use the same parametric variable r. And look, it does slide on top of the green line. So we know that it's B, and we haven't even tried C and D, but we know B already works, so the solution is B.